Voyager has just transmitted data that dramatically changes our understanding of space. Contrary to the long-held belief that space is a silent, peaceful void, it turns out to be alive with astonishing forces. After journeying over 14 billion miles from Earth, Voyager 1 has entered interstellar space, where it has detected powerful magnetic fields and unusual energy waves. This revelation raises profound questions. Have we fundamentally misunderstood the nature of the cosmos? Let's explore this groundbreaking discovery and what it might mean for the possibility of lethal alien life forms. One of Voyager's most remarkable findings is the presence of a new magnetic field at the boundary where our solar system meets interstellar space. Scientists previously assumed that the sun's magnetic influence would diminish after crossing the heliopause, the outer edge of the solar wind's reach. However, Voyager found that instead of weakening, the magnetic field becomes stronger and more intricate. This surprising fact challenges our previous knowledge about the solar system's limits and the environment beyond it. The ramifications extend beyond academic interest. They affect how we might shield Earth from cosmic radiation and how future space missions could be planned. Is this newly found magnetic force a potential resource, or does it signify hidden dangers we have yet to comprehend? But Voyager's discoveries don't stop there. Another unexpected observation involves cosmic rays, which are high-energy particles originating from violent events such as supernova explosions. As Voyager crossed into interstellar space, it encountered a surge in cosmic ray intensity. This suggests that the solar system's protective bubble, which was believed to deflect much of this radiation, is less effective than scientists had hoped. This raises troubling concerns. Are astronauts equipped to handle such intense radiation? During long-term missions, could these cosmic rays hint at even greater, unseen hazards lurking in the vast universe? These insights underscore how little we truly know about conditions beyond our solar system and highlight the real risks involved in deep space exploration. Moreover, Voyager's instruments have detected a turbulent interaction of magnetic fields and charged particles, or plasma, right at the heliopause, contradicting the earlier assumption that this boundary would be smooth and predictable. Instead, Voyager recorded strange fluctuations that don't fit existing scientific models. These anomalies could be manifestations of unknown forces with significant implications not only for human exploration but also for Earth's protection. As NASA and private companies like SpaceX gear up for missions to Mars and beyond, these findings necessitate a fresh evaluation of our approach to interstellar travel. Voyager has stood as a beacon of human creativity and exploration for decades. Its unexpected revelations showcase both the durability of the spacecraft itself and the brilliance of the teams behind it. Even though Voyager is now so distant that its signals take nearly 24 hours to reach Earth, it continues to send back invaluable data. This feat is a testament to the careful design and planning that went into the mission, but it also raises concerns about how long the spacecraft can keep functioning. Its power supply is dwindling, and a future gap in crucial space information may be imminent. Despite these challenges, Voyager's findings have the potential to revolutionize our understanding of the universe. From irregular magnetic fields to unexpected radiation levels, the spacecraft has uncovered clues that could lead to breakthroughs in spacecraft propulsion or protection technologies. Such advancements might enable safer and more ambitious journeys through space. However, these discoveries also confront us with stark realities. What if these forces are not just scientific curiosities but genuine threats to human survival beyond Earth? Balancing the desire to explore with the need for safety becomes a crucial question. The increased cosmic ray activity near the heliopause is not just an issue for future space travelers, it has broader consequences for Earth as well. Elevated radiation levels could interfere with satellite operations, GPS accuracy, and global communication networks. Imagine a world where the technology we depend on daily suddenly becomes unreliable due to cosmic forces. These risks illustrate the deep connection between space and Earth, emphasizing the necessity for comprehensive strategies to address these hazards. Ethically, the findings raise important questions. Should we continue to push the boundaries of space exploration despite the poorly understood dangers? What duties do we owe to astronauts who face these unknown risks? Voyager's journey also challenges our understanding of the interstellar medium, the matter and energy filling the space between stars. The spacecraft's instruments have observed unexpected irregularities in how the solar wind interacts with cosmic dust, suggesting the presence of unfamiliar forces. Could these be relics of ancient cosmic phenomena, or entirely new entities? The answers could reshape our knowledge of the universe's structure and history, yet they also introduce uncertainty. If these forces prove more hazardous than expected, they could jeopardize missions to the Moon, Mars, and beyond. Yet it is not all bleak. Voyager's data might help scientists develop new technologies to mitigate these dangers. For instance, a better understanding of cosmic rays and magnetic fields could lead to improved spacecraft shielding and radiation protection systems, making long-duration space travel safer. Studying these phenomena could also inspire innovative propulsion, methods that allow faster and farther journeys. In this way, Voyager's discoveries serve as both a warning and an opportunity. The urgency of these revelations cannot be overstated as national space agencies and private companies accelerate their ambitions. Missions such as SpaceX's goal of colonizing Mars or NASA's Artemis program to return humans to the Moon must factor in the harsh realities revealed by Voyager. The stakes are immense. Failing to address these challenges could have catastrophic consequences for space exploration and life on Earth. Voyager's missions remind us that exploration entails both risks and rewards, pushing us to think bigger, adapt faster, and prepare more thoroughly. As humanity stands on the threshold of a new era of space exploration, Voyager's legacy offers both guidance and caution. The universe is vast, unpredictable, and filled with wonders, but it is also fraught with immense dangers. The question is not whether we will continue to explore, but how we can ensure that this exploration benefits all of humanity. Perhaps Voyager's most significant contribution is not merely the data it has sent back, but the profound questions it compels us to ask. What else awaits discovery in the cosmos? Are we ready to face the challenges of venturing into the unknown? And, crucially, how can we apply this knowledge to secure a better future for Earth and beyond? The answers to these questions will shape the next chapter of human history, one written among the stars. Reflecting on Voyager's findings prompts us to consider how humanity began its journey into space and what was learned along the way. Since ancient times, people have gazed at the stars, wondering what lies beyond. For most of history, we could only speculate. The 20th century changed everything with advances in technology that allowed us to leave Earth. Rockets, those massive, roaring machines, finally made it possible to escape Earth's gravity and explore the cosmos. The real turning point came in 1957 when the Soviet Union launched Sputnik 1, a small metallic sphere that emitted radio beeps as it orbited Earth. Although simple, Sputnik sent shockwaves around the world. It was the first human-made object to enter space, opening the floodgates for space exploration. Just 4 years later, Soviet cosmonaut Yuri Gagarin became the first human to orbit Earth, completing a 108-minute trip that forever altered humanity's relationship with the universe. Humans were no longer mere observers of the stars. We were now participants in the vast cosmos. The United States quickly joined the space race. In 1961, Alan Shepard became the first American in space, though his flight lasted only 15 minutes. The following year, John Glenn orbited Earth 3 times, demonstrating America's growing commitment to space exploration. These early missions, part of NASA's Mercury program, were designed to test whether humans could survive and function in space, and they proved that we could. The intense rivalry between the U.S. and the Soviet Union propelled space exploration to incredible new heights. In 1963, Valentina Tereshkova became the first woman to orbit Earth, spending 3 days in space and circling the planet 48 times. This was not only a Soviet victory, but also a significant milestone for women in space. The most iconic moment of this era came in 1969 when NASA's Apollo 11 mission landed astronauts on the Moon. Neil Armstrong's famous words, "That's one small step for man, one giant leap for mankind," were broadcast worldwide. The moon landing was more than a scientific achievement. It was a bold statement that humans could dream bigger than ever before. After the Apollo missions, the focus shifted from brief visits to longer stays in space. The Soviet Union launched Salyut 1 in 1971, the first space station that allowed cosmonauts to live and work in orbit for extended periods. NASA followed with Skylab in 1973, where astronauts stayed for missions lasting up to 84 days. These orbital laboratories were crucial stepping stones for future exploration.